This is 2024, the deferred paper. It's question 4 and it's the question on trigonometry. So obviously we're on paper 2. So question 4, part A, find the value of cos 105 degrees without using a calculator. Now when they give you these questions, they'll always give you, this is not just a random number, it's always a special number that you can convert into what we call special angles. So 105, if you take a quick look at it, can be rewritten as 60 plus 45. And the reason I picked those two is because they give me special angles in the tables. On page 13 in the tables, you've got special angles like 60, 45, 30, etc. And that's what he's getting at here. Can you break this down into special angles? Now if you can do that, another formula from the tables comes to our assistance. There's a formula for cos A plus B in the tables. And if you look up the formula, you'll see it's the cos of A, cos B minus sin A, sin B, or in our case, cos 60, cos 45 minus 6 sin 60, sin 45. If you look up those in the tables, again on page 13, you'll find the answers are given to you. Cos 60, so this is without using a calculator. In other words, we're using the tables. Cos 60 is a half, cos 45 is 1 over root 2, etc. Fill in those 4 values. And then just tidy up. It's the same common denominator, 2 root 2, so that's the common denominator, and it's just 1 by 1 is 1 minus root 3, and there's your answer. That's the way that we're supposed to write it, just like this. 1 minus root something over something root something. Okay, moving on to part B, a proof. This is one of the 8 proofs that are mandatory on the course. So you can always start a proof. Your starting point can be the result of a previous proof. They're in order in the tables. So if you take your starting point as a previous proof, which is that sin A plus B is sin A cos B plus cos A sin B, and again you can look up this on in the tables. It's in the tables. Now the big step here is this says that sine of any angle plus any other angle, basically, whatever you want to call them, A and B or whatever. So why don't we just call the second angle A? Why don't we make two of them the same? There's no reason why not, because B can stand for any angle. And that's what we do. So it becomes the sine of A plus A, and the cos of B becomes the cos of A, sine of B becomes the sine of A. So you end up with sine A cos A plus cos A sine A. So you have the same thing twice, basically. So it's twice sine A cos A. And it's as simple as that. That's the proof done. We're given a triangle here, ABC. We're told AB is 5, AC is 3, and the angle ABC is W. Okay, so this line is kind of a waste because it's all on the diagram. Make the diagram work for you, basically, yet again. That's paper 2 especially, the diagram, make the diagram do the work is a big technique that will really help in lots of questions. Sometimes it's my own personal preference. I almost just, once I've read that and I think I can see it's on the diagram, I just cross out that line altogether so that it's not confusing me, basically. So I can focus on what's really important here. Anyway, so all that first line is covered on the diagram. It's shown clearly on the diagram. Find the value of cos W in the form P over Q. Okay, so and we're asked, the examiner's being very fair to us. We're being told to use the results from the last part, which is the proof, and the sine rule here. So we're being told to use the sine rule. So it's great. We don't have to worry about what rule to use. We're told which one to use. So the sine rule basically says that any side over the sine of the opposite angle, so A over sine A, basically is B over sine B. So that's it. It's a pattern. 3 over sine W is 5 over sine 2W. That's the sine rule. That's what, or the other way around, same thing. You can put the angle on top if you like. So sine W over 3 is sine W over 3 is sine 2W over 5. Now he gives us this straight hint as well to use the result in the last part, which was of course that if you look back to the last part for a sec, we're told that the sine of 2A is 2 sine A cos A. The sine of 2A is 2 sine A cos A. And that's exactly what we have here, 2W sine 2W. So using the proof, that means we've got 2 sine W cos W, which is, that means now that the sines cancel. It's the same on both sides, so you can cancel the sine W on both sides. And you're left with 2 cos W over 5 is 1/3, you can multiply across by 5 and you get 5 over 3 is 2 cos w, and divide across finally by 2 and you get 5 over 6. 2 by 3 is 6 is cos w. And that's what we were asked for, write it as a fraction. And that's the end of the trigonometry question.